Imagine staring into the sky, watching the moon slowly slide across the sun, darkening the world in broad daylight. It feels almost magical, ancient, and mysterious. But what if I told you that this upcoming the one happening next week, is hiding something deeper than just the moon blocking out the sun? What if NASA knows more than they're saying? What if this celestial dance is not just an astronomical event, but a doorway? Total eclipses have fascinated humanity for thousands of years. From the earliest civilizations carving them into stone to modern-day scientists launching high-altitude balloons to observe them, eclipses have always held a certain power, not just visually, but emotionally, psychologically, and yes, scientifically. But this one is different. NASA's public announcements have focused on visibility zones, peak durations, and safe viewing protocols. But beneath the press releases and public outreach lies a layer of classified preparation, unusual data streams, and subtle changes in how this event is being approached. The question is, why? Let's rewind a bit. Total eclipses aren't rare, but their paths of totality are incredibly specific. The Earth, Moon, and Sun have to align with pinpoint accuracy. When they do, it's like the universe flips a switch. Temperatures drop, birds go silent, and day turns to night. With this coming eclipse, its path slices across several major observatories and even intersects with high-altitude U.S. military surveillance zones. Coincidence? Maybe? Or maybe not. Because behind the scenes, something strange is happening. In the last few weeks, a handful of amateur astronomers and independents began noticing an anomaly, and unexplained signal appearing in the upper solar corona just days before the eclipse. Faint but persistent. Not a solar flare. Not magnetic interference. Something else. It's as if something near the sun is pulsing artificially in a rhythm that doesn't belong to solar activity. These observers shared their findings on fringe forums, and the posts quickly disappeared. Accounts were banned, and then, curiously, several of those same accounts began posting that it was all a mistake, that it was just an equipment error. The tone didn't match the original users, almost like someone else had taken over. NASA, of course, hasn't acknowledged any such signals. Officially, they're prepping for a routine observation campaign, but satellite tasking logs if you know where to look show an unusual concentration of assets being positioned over the eclipse path. Not just scientific satellites, defense ones, surveillance ones, a few in orbits that aren't supposed to be public knowledge at all. It's as if they're not just watching the eclipse, they're watching for something that might come with it. Some speculate it's an inbound object, something hiding in the sun's glare, like the infamous Black Knight satellite myth. Others believe this eclipse might activate something dormant in ancient structure on Earth, perhaps, or a frequency only triggered when solar radiation drops to a specific threshold. There is even chatter among fringe physicists that the eclipse's gravitational alignment creates the perfect conditions for quantum anomalies, brief, barely measurable tears. And then there's Project Helios, officially mothballed since 2009. Helios was a classified NASA initiative meant to explore high-energy solar events, using experimental tech, some of which allegedly never saw public testing. But last week, one of the primary Helios modules was quietly its signature ping detected by radio astronomers tracking deep space objects. Why bring back a dormant solar monitoring system days before an eclipse, unless you expect something extraordinary? But let's take a breath. What if all this is coincidence? Just data noise, misread signals, internet paranoia? The answer might lie in the past. In 1973, during another total eclipse, a classified U.S. Air Force surveillance balloon detected a brief pulse of high-frequency radiation, not from the sun, but from the shadowed side of the moon. It lasted less than 3 seconds. The data was buried, the mission logs redacted. It was never explained. Some thought it might have been a glitch. Others weren't so sure. Now here we are, 5 decades later, facing an eclipse, crossing over key geomagnetic zones, areas known for strange atmospheric behavior. NASA says it's nothing unusual, but their coordination with NORAD, the National Reconnaissance Office, and even NOAA's deep-sea monitoring stations suggest something larger is at play. Why would undersea stations care about a solar eclipse? Unless there's concern about effects beneath the crust, not just above. Some insiders claim NASA is watching for a gravitational anomaly, a temporary distortion of Earth's magnetosphere that could reveal something, hidden something cloaked, not by technology, but by physics itself. Think about it. What better time to scan the invisible than when the sun's overpowering radiation is momentarily blocked and the Earth's electromagnetic field is in flux? It wouldn't be the first time a celestial event revealed what wasn't supposed to be seen. There's historical precedent: auroras lighting up ruins in the Arctic, strange echoes and sonar readings following lunar eclipses, even ancient cave paintings that seem to show the sky tearing open during an eclipse thousands of years ago. What were they seeing? NASA knows the public will be watching next week. That's the beauty of an eclipse. It's too big to hide. But what they aren't saying is what they'll be doing behind the curtain. High-altitude balloons fitted with experimental optics, drones launched from aircraft carriers timed with the moment of totality, ground-based sensors recalibrated for frequencies that don't normally pass through the atmosphere. If this was just about the eclipse, why all the exotic hardware? The timing is too precise. The silence is too loud. When asked directly in a press conference last week if there were any concerns about gravitational interference or solar anomalies during this eclipse, NASA's spokesperson paused just for a second, then smiled and said, "It'll be one to remember." That's not nothing. That's a loaded answer wrapped in PR. What if the sun isn't just a source of light, but also a filter, something that masks signals from beyond? And what if, during totality, that filter turns off for just a moment, allowing something else to slip through? We often think of space as silent, but during an eclipse, the silence changes. The solar wind drops. Earth's ionosphere dips. It's a moment of cosmic stillness, and in stillness, things surface. Think about all the data we've been gathering from the James Webb Space Telescope, from Parker's solar probe, from Earth's own ionospheric sensors. There's more we're learning about the sun than ever before. But there's also more we're not being told. You can't put all this coordination, all this hardware, all this secrecy into play without purpose. And no, it's not about pretty eclipse pictures. It's about catching something that can't be seen any other way. The ancient Babylonians believed eclipses were messages from the gods, warnings or prophecies. Modern science laughs at that. But what if they weren't wrong? What if they were just using different language to describe the same phenomena? Warnings don't have to come in thunder. Sometimes they come in silence, in shadow, in that eerie stillness, when the sun disappears. Next week, when you watch the eclipse and the world goes dim, remember, somewhere out there, in a desert bunker or a lab buried under Colorado, someone is watching more closely than we are. Not because it's beautiful, but because it's revealing. Something is coming into view. And NASA isn't telling us everything. Keep your eyes on the sky, because the sun may be blocked, but the truth is about to shine.